know what rain feels like. You have stood under a gray sky while water fell in soft drops, each one small enough to sit on your skin before sliding away. You have watched puddles form, watched streets turn into mirrors, watched clouds decide the rhythm of a day. It feels ordinary, predictable, but even here, on Earth, rain is already a strange thing. It falls from kilometers above you. Each drop forms around invisible particles in the air. Entire weather systems move across continents just to decide where those drops will land. And yet, this is familiar. You expect water. You expect clouds. You expect gravity to pull everything down in a straight, gentle fall. Now imagine standing on another world. You look up, waiting for rain, and the sky begins to fall in glass. Not water, not even ice, molten glass. On a distant exoplanet known as HD 189733b, scientists have measured winds moving at over 8,000 kilometers per hour. That is faster than a bullet. In that chaos, tiny particles of silicate, basically sand, are heated until they melt, then blasted sideways across the planet in a storm of burning shards. Rain still falls, just not like you remember. And this is only one world. Beyond our sky, orbiting distant stars, there are planets where iron condenses into droplets and falls like metallic rain. Planets where the ground may not exist at all, only endless oceans, thousands of kilometers deep. Worlds where gravity crushes everything flat, and others where it barely holds you down. Each one obeys the same laws of physics. Each one follows the same rules, but the outcomes are unfamiliar. And if the environments are this different, then life, if it exists, would not look like anything you recognize. Not animals with eyes and limbs and lungs. Something else. Something shaped by alien skies, alien gravity, alien chemistry. Because life does not design itself, it adapts. On Earth, every creature is an answer to a problem. Fish answer the problem of water. Birds answer the problem of air. Trees answer the problem of sunlight. Change the problem, and you change the answer. So what happens when the problem is a planet where the air is thick like liquid, or where the sun never truly rises, or where a single day lasts longer than an entire human lifetime? You are about to leave everything familiar behind. And once you see what might exist out there, coming back to Earth will feel very small. Start with something simple. Take a breath. Air moves into your lungs. Oxygen passes into your blood, and your body quietly converts it into energy. You do not think about it. You do not need to. But this only works because the air around you has the right pressure. Not too thin, not too thick. Just enough to let your lungs expand and contract with ease. Now change that. On some exoplanets, the atmosphere could be so dense that breathing would feel like trying to inhale underwater. Not impossible, but heavy, slow, resistant. In that kind of world, flying would not require wings like birds have on Earth. The air itself would hold you up. Creatures might drift instead of walk. Bodies wide and flat like living sails. Movement would be slow, graceful, almost silent. You would not hear footsteps, only the pressure of air shifting. And then, go further. There are planets where gravity is much stronger than on Earth. Even a small increase changes everything. Double the gravity, and your body would weigh twice as much. Your bones would strain. Your muscles would burn just to stand. Now imagine life evolving there. Nothing tall, nothing fragile. Everything would be low to the ground, thick, compact, built to endure weight. Creatures might look like moving stone, pressed down by a force they can never escape. Jumping would be impossible. Running would be rare. Survival would mean staying close to the ground, always. A single step would matter. And then there are worlds with less gravity. On a planet smaller than Earth, gravity weakens its grip. Movements become effortless. A small push could send you drifting for meters. Life there would stretch upward, tall, thin, fragile-looking, but perfectly adapted. Creatures could leap enormous distances. Some might never touch the ground for long, gliding slowly through the air like drifting seeds. Imagine an animal that spends most of its life falling and never hits the ground too hard. Now consider light. On Earth, the sun rises and sets every 24 hours. Life has adapted to that rhythm: sleep, wake, repeat. But not all planets spin this way. Some are tidally locked, one side always facing their star, the other locked in permanent darkness. One half burns, the other freezes. Between them is a narrow band, a thin strip where temperatures might allow liquid water to exist. This is where life would gather, forever trapped between extremes. On one side, endless day. On the other, endless night. Creatures here would never know sunrise, never see a sunset. Only a constant glow on the horizon, and evolution would follow that light. On the dark side, eyes might grow enormous, sensitive enough to detect the faintest glimmer. On the bright side, vision might disappear entirely, replaced by thick shielding or entirely different senses. Because sight is not required, only survival. And now, a deeper shift. Water. You think of oceans as vast, and they are. The deepest point in Earth's oceans, the Mariana Trench, reaches about 11 kilometers down. That is enough to crush a submarine if it goes too far. But there are exoplanets, water worlds, where oceans could be hundreds of kilometers deep. No continents, no land, just water. At those depths, pressure becomes unimaginable, not just crushing but transforming. Water itself begins to behave differently, forming exotic forms of ice that exist even at high temperatures due to the immense pressure. The surface might look calm. Below, it becomes alien. Life, if it exists there, would never see the surface, never know the sky. Entire ecosystems could exist in darkness, feeding on chemical energy instead of sunlight, similar to hydrothermal vent life on Earth, but on a planetary scale. An entire biosphere, hidden. And then comes the gut punch. There are more planets in our galaxy than stars. The Milky Way alone contains an estimated 100 billion stars, and current data suggests that most of those stars have planets. That means there could be hundreds of billions of worlds, each one with its own conditions, each one with its own possibilities. Even if only a tiny fraction can support life, that still leaves millions of living worlds. Millions. You are not standing in a rare place. You are standing in one example, just one. And now, think about chemistry. Life on Earth is based on carbon. It builds complex molecules, flexible structures, adaptable systems. But carbon is not the only option. Silicon, for example, can form similar bonds, not identical, not as versatile, but under different conditions, different temperatures, different pressures, it could form the basis of something alive. Not trees, not animals, something slower, more rigid, perhaps more durable. Imagine a creature that grows like crystal instead of flesh, not breathing, not eating in the way you understand, just assembling itself from its environment, slowly, over centuries. And now the question becomes unavoidable. If life can take so many forms, if environments can vary this wildly, if the universe provides endless combinations of pressure, light, gravity, and chemistry, then what is the limit? What is the strangest thing that could still be called alive? And more importantly, would you even recognize it if you saw it? You began with rain, a simple, familiar thing, water falling from the sky. Now you have seen worlds where the sky itself behaves differently, where gravity reshapes bodies, where light never changes, where oceans hide entire ecosystems beneath crushing depths. And through all of it, one idea remains constant. Life adapts. It does not aim for beauty. It does not aim for complexity. It does not aim for intelligence. It aims for survival. That is all. On Earth, that process has produced forests, oceans, animals, and eventually, you, a creature capable of asking questions about worlds it has never seen. But there is nothing in the laws of physics that says life must look like this. Nothing that says it must have eyes, or limbs, or thoughts. Those are just solutions, temporary answers to specific conditions. Change the conditions, and the answers disappear. Out there, across the vast distances between stars, there may be creatures that do not move, creatures that do not think, creatures that exist on timescales so slow that a human lifetime would look like a single heartbeat to them. Or the opposite, life that burns bright and fast, living entire existences in seconds. You would not be able to speak to them, you might not even notice them, and yet they would be alive, just as real as you, just as shaped by the same universe. And that changes something. Because when you look up at the night sky, you are not just looking at distant lights, you are looking at possibilities, at environments where the rules you take for granted are rewritten in subtle, powerful ways. The universe is not strange, it is consistent, it follows its laws perfectly. It is your expectations that are small. You evolved to understand one narrow set of conditions, one type of gravity, one type of atmosphere, one cycle of day and night. Everything else feels alien, but to the universe, it is all normal. And somewhere, perhaps on a planet you will never see, under a sky you cannot imagine, something may be living its entire existence without ever knowing what a human is, without ever knowing what Earth is, without ever knowing that you are here, asking these questions. And that realization does not make you insignificant. It makes you rare in a different way. Not because you are the only form of life, but because you are a form of life that can wonder about all the others. You can imagine glass rain. You can picture oceans deeper than mountains are tall. You can stand on one small planet and think about billions more. That is not small. That is extraordinary. And yet, it is quiet. Because the universe does not pause for these thoughts. It does not react. It does not answer. It simply continues. Stars form, planets drift. Life, if it exists, adapts in silence. And you are here, for a brief moment, aware of it. A thin layer of consciousness on the surface of a small world, orbiting an ordinary star, in one galaxy among billions. You are not at the center. You never were, but you are part of it. And that may be enough, because somewhere, far beyond anything you will ever touch, the universe is still building new worlds, still testing new conditions, still asking the same question over and over again. What can exist here? And it never needs to hear the answer.